In this video, I'm going to show you step by step how to integrate industrial data into AWS IoT Sitewise using MQTT Sparkplug. To demonstrate, I'm going to use this Groove Rio as my data source with my temperature probe representing the temperature of a wind turbine system and my 0 to 10 volt signal generator representing wind turbine speed. Gathering data from hundreds or thousands of different types of industrial assets to extract information that could help transform a company's business processes is a time-consuming and expensive process, mainly because industrial data is mostly available as discrete data points, which makes it difficult to analyze assets as whole units using either simple visualization or advanced analytics tools. AWS IoT Sitewise is a platform that aims to solve this problem by providing an asset modeling framework that enables you to define the different types of assets and their respective data points by creating asset models for each type, followed by the creation of instances or virtual representations of real assets in the field based on the models, and then updating data points of your virtual assets in real time with data collected from your plant. However, you have to manually create asset models for each type of asset in the plant, and also manually create instances of all your assets. Now, if you have thousands of assets, this would not only be a slow process, but it would present challenges such as the accuracy of your data models and instances, among many other challenges. MQTT Sparkplug helps to eliminate these challenges, and here is how. Sparkplug allows you to transmit straight from the source asset models, respective instances of the assets, and the sensor measurements to update the data points of virtual representations of your assets into AWS IoT Sitewise. To demonstrate this, I'm going to use an Opto22 Groove Rio as my data source at the edge. I'll expose its temperature and speed measurements representing wind turbine data via an OPC-UA server embedded on the device. I'll then use Inductive Automation's ignition gateway together with an ignition module from CirrusLink called MQTT Transmission to collect data from the OPC-UA server and transmit it only when change is detected to a HiveMQ MQTT broker, which I'll deploy on the AWS Cloud Platform. Next, I'll use the IoT Bridge for Sitewise software from CirrusLink to connect to the HiveMQ MQTT broker and forward my data to the AWS IoT Sitewise platform, which then makes it available to many sophisticated analytics tools on AWS. So let's get started. Let us begin by exploring the AWS IoT Sitewise interface. I'm on my AWS console page. I'll proceed by clicking on Services here. And then under Internet of Things, select IoT Sitewise. This takes me to the AWS IoT Sitewise page. And if I click on the menu here, you can see options for building models, assets, and data streams. I'll proceed by clicking on Models. You can see we have no models here. And if you want to create a model, you click on the Create Model button here. This will allow you to specify the details of your model, its attributes, metrics, text, and so on. Next, when I click on Assets here, you can also see here that I have no assets, but I do have an interface for creating assets. Again, we're not going to be creating any assets here manually. Instead, we're going to automatically create instances here by publishing them from the source of the data at the edge using MQTT Sparkplug. Now that we are familiar with the IoT Sitewise Cloud interface, let's go ahead and start putting our components together to integrate MQTT Sparkplug data with IoT Sitewise. One thing that we need to take note of here before we move on is our AWS IoT Sitewise region, which is US East 1, North Virginia in this case. The first component of our system that I'm going to deploy is my HiveMQ MQTT broker on AWS. The first step is to open up the HiveMQ website, and then proceed by clicking on the Get HiveMQ button. And then on this page here, I'll scroll down. So to deploy my HiveMQ broker, I'm going to use an Amazon Machine Image, or AMI in short, which will provide us with the required information to launch a virtual machine on an AWS EC2 instance. So I'll proceed by clicking on HiveMQ AMI for AWS. Next, I need to select a region where I want to deploy my HiveMQ MQTT broker instance to. I'll select East US 1, North Virginia. And when I do that, it takes me to the page for launching an EC2 instance on AWS. First, I'll give my deployment a name. I'll call it my HiveMQ MQTT server. And when I scroll down, you can see that I've got an Amazon Machine Image for HiveMQ version 4.8.3 already pre-populated for me. Next, I'll scroll down to the instance type section. Under instance type here, I'll click on the drop-down selection and I'll select M5.xlarge, which provides us with 4 CPUs and 16 GB of memory in order for us to fulfill the minimum requirements for a HiveMQ MQTT broker. Next, I need to create a key pair here in order for me to securely connect to my instance. So I'll click on Create New Key Pair. I'll call it my HiveMQ demo instance, and then here under key pair type, I'll select RSA encryption, and because I'll be using PuTTY to connect to my instance, I'll select .ppk under private key file format. And then I'll click on the Create Key Pair button. And when I do that, it downloads a .ppk file onto my machine. And then next, we move on to network settings. Now, because we want to configure some custom settings here, I'll click on Edit. I'll leave these settings at the top as default. And then I'll give my security configuration a name. Next, I'll click on Add Security Group Role. Make sure Custom TCP is selected. And then put 1883 under port range in order to expose the port so that my HiveMQ instance is accessible to MQTT clients. And because I want my HiveMQ instance to be accessible from anywhere on the internet, I'll select Anywhere under source type here. I'll click to add another security group rule, and this one is for allowing access to my HiveMQ control center at port 8080. And the same goes for port 22, which is for SSH access. Okay, so we've finished our security configurations. Now we move on to configure storage section. The minimum recommended amount of storage for HiveMQ broker is 20 GB. So I'll leave that as default. And then finally, we move on to the summary section. Here you can change the number of instances, but for our use case, one instance would be enough. So here I'll click on Launch Instance. So my deployment is complete, and you can see here under EC2 instances that I have my HiveMQ MQTT server running. I'll proceed by clicking into the instance, and you can see here this is the public IP address of my HiveMQ MQTT broker instance. So I'll copy that, and I'm going to use it to access my HiveMQ control center. So this means that my HiveMQ MQTT broker has been successfully deployed on AWS EC2 instance. Next, I'm going to show you how to install the IoT Bridge for Sitewise application. Now, IoT Bridge for Sitewise is an Amazon Machine Image product that we need to deploy on an AWS EC2 virtual machine. And because I'll need to remotely access the terminal of that virtual machine via SSH, I'll need to begin by creating an AWS EC2 Key Pair, which will allow me to securely access the virtual machine terminal. To do that, I'll go to my EC2 dashboard, and then under Network and Security, I'll select Key Pairs. Next, I'll click on the Create Key Pair button, and then I'll give my key pair a name. I'll call it my IoT Bridge Instance, and then I'll make sure to select RSA for key pair type, and then under Private Key File Format, I'll select .ppk since I need to use PuTTY to access the terminal. And then here I can add a tag to identify my instance, and then finally I'll click on Create Key Pair. And when I do that, a private key file is automatically downloaded onto my computer. So now that I've created my key pair, I can start installing my IoT Bridge for Sitewise software. The first step is to visit the Amazon Marketplace website. And then on the Amazon Marketplace webpage, I'll need to type in IoT Bridge for Sitewise. And then press Enter. Next, I'll click on IoT Bridge for Sitewise by Cirrus Link. And then here, I'll click on the Continue to Subscribe button. Accept the terms. And then click on the Continue to Configuration button. Now on this page, I need to begin by choosing a delivery method. I'll select Cloud Formation Template from the drop-down options. And when I do that, this sets up some defaults, including a field for the Cirrus Link IoT Bridge for AWS Sitewise template, software version, and the region. For the region, I'll make sure that I'm deploying my IoT Bridge for Sitewise on the same region as my IoT Sitewise platform. And then from here, I can go ahead and click on the Continue to Launch button. This brings up a review page. I'll scroll down, and here under Choose Action, I'll select Launch Cloud Formation, and then click on Launch. This brings up the Cloud Formation stack creation page, which is pre-populated with the required template. So here I'll click on Next, and this brings up the stack configuration page. Now here I need to set the stack name. Under instance type here, I'll leave it as default. And then under key name, I'll select the key pair that I created for this instance, which is my IoT Bridge instance. And then for the SSH location, I want to make it accessible from anywhere on the internet. So I'll put this IP address, and this can be changed later if you want to restrict it to a particular IP address. And then I'll click on Next, and this brings up the Configure Stack Options page. Now here, I just need to make sure the Rollback All Stack Resources option is selected in case there is failure in deployment. I'll click on Next, and this brings up a review page. Here I need to accept the IAM changes that the IoT Bridge Cloud Formation deployment makes to my AWS account. And then finally, I'll click on the Create Stack button. My deployment has begun, and it should take a few minutes to complete. Okay, so the deployment of my IoT Bridge for Sitewise is complete. So we move on to the next step. The next step is to configure my IoT Bridge for Sitewise application. To access the Ec2 instance using PuTTY, I first need to get the public IP address of my instance. So I'll go to my EC2 dashboard, select instances, click into my IoT Bridge Sitewise instance, and then copy the public IP address here. Now, because IoT Bridge for Sitewise uses Ubuntu image, my instance username is Ubuntu. Now that I have this information, I'll start party, and then I'll enter my instance username and public IP address in the hostname field. Next, under connection here, I'll expand SSH, select auth, click on browse, and then navigate to my .ppk file that was downloaded when creating my Ec2 Key Pair. And then when that is done, I will proceed by selecting open. IoT Bridge for Sitewise is configured with a configuration file called ibus.properties. So I first need to navigate to the file using the following path. Now, once my IoT Bridge for Sitewise configuration file is open, I need to configure the various options in this file. So here, I'll enter details of my HiveMQ MQTT broker that I deployed on AWS. And then under MQTT server name here, I'll enter my HiveMQ MQTT server. So in my case, I have no username and password, but if you're using security on your broker, which you should, you can enter the details here. I'll leave the following options as default. So I've finished configuring my IoT Bridge for Sitewise to point it to my MQTT broker on one end and my IoT Sitewise platform on the other end, while leaving the rest of the details as default. So I'll go ahead and save this. And then I need to restart my application using the following command. Okay, so my IoT Bridge for Sitewise has been successfully configured. So now we can move on to the next step. The next thing that I'm going to do is to show you how my hardware is configured. So here I have a Groove Rio remote I/O device, and connected to channel 0 of its I/O interface is this temperature sensor representing the temperature of my wind turbine system. And on channel 1, I've got this 0 to 10 volts signal transmitter representing the speed of my wind turbine in RPMs. Now the Groove Rio is exposing these values using its embedded OPC-UA server. So I'm going to be reading these values and mapping them onto an instance based on a wind turbine model that I will create on Ignition and publish to IoT Sitewise. Before we go on, let's quickly go to the Groove Rio web interface to see the data points. On the Groove Rio web interface, I will click on I/O channels, and here you can see the temperature and turbine RPMs. Now I've scaled my 0 to 10 volt signal to represent 0 to 20,000 RPMs. So if I turn down my signal, you should see this value change. Next, I'll go back to the home page and then click into data service. This is where my OPC-UA configuration is done. Okay, so now that you understand the setup of my hardware here, I'll move on to the next step, which is configuring my Ignition and MQTT transmission modules. Now that my edge device is configured and exposing the data that I need, and my IoT Bridge is configured and ready to receive the data, I need to get data flowing into IoT Bridge for Sitewise by setting up Inductive Automation's Ignition platform with the MQTT transmission module from SiriusLink. I already have Ignition installed on my computer and I'm logged into the Ignition web interface. First of all, if I go under OPC connections here, you can see that I have a connection to my Groove Rio OPC-UA server. And when I launch my OPC client, you can see that we are indeed accessing temperature and turbine speed variables from my Groove Rio. To proceed, I will launch my Ignition Designer software. Once it is launched, I will expand my MQTT tags from my transmission module under the tag browser. And then I'll go ahead and delete these example tags. Next, I will click on the UDT Definitions tab, and then I will click on the plus sign here and select New Data Type. This opens a dialog box, and here I can give my UDT a name. So you see, here we are essentially creating a model. And since I want to create a model for a wind turbine, I'll call my UDT wind turbine. Next, I'll use this new member tag button to add metrics to my UDT, which are essentially properties of my wind turbine model. I'll click on the button and select memory tag. So here I need to set the name of my tag to temperature, which is my first property. Set its data type to float, and the engineering units to Celsius. Next, I'll add another tag to my UDT. And this time I'll call it turbine speed. I'll set its data type to integer and engineering units to RPM. So that's my UDT representing a basic wind turbine model. Now when that is done, I'll switch back to the Tags tab and right click on PLC1, go to Add New Tag, Data Type Instance, and Wind Turbine. So what I'm doing here is essentially creating an instance of a wind turbine using the UDT or wind turbine model that I just created. So I can call this Wind Turbine 1. Here I'll click on temperature, and then under value source, select OPC. And then here under OPC item path, I can specify the path of my value. So I need to get this from the Groove Rio OPC-UA server. Next, I'll go to my turbine speed and do the same. And when that is done, I'll click on Apply and OK. And then there you can see our temperature and turbine speed for our Wind Turbine 1 instance. Now, if I was to create a second Wind Turbine instance here, say Wind Turbine 2, I would use the same UDT or Wind Turbine model and then point to a different data source for mapping to its properties. So if I adjust my turbine speed here, you can see it change. So I've successfully defined and configured my UDT on Ignition, which will map to a Sitewise asset model. And I've also created a UDT instance, which will map to a Sitewise asset. To start publishing this information as Sparkplug messages, I need to configure my MQTT transmission module to point to my HiveMQ MQTT broker on AWS. To configure my MQTT transmission module with HiveMQ MQTT broker details, I need to go back to my Ignition Gateway web UI. And then here under Config, I'll go to MQTT Transmission and select Settings. And then here I'll go to the Transmitters tab. Click on Edit under Example Transmitter. Scroll down. And then make sure that Convert UDTs is unchecked. This will automatically check the Publish UDT definitions in path, so make sure that is checked. Next, I'll select the Servers tab and make sure that I've got the Settings tab selected here. This is where I need to enter my HiveMQ MQTT broker details. First, I'll delete the existing Charlotte SCADA server. And then create a new MQTT server. I'll call it my HiveMQ MQTT server. And then I'll enter the URL of my HiveMQ broker. And then I'll go ahead and click on Create New MQTT Server. So what that means is that my wind turbine data should be flowing into AWS Sitewise. To find out, I'll go to my AWS console and select IoT Sitewise. And then here on the menu, when I click on Models, you can see that I now have a wind turbine asset model in Sitewise that corresponds to my wind turbine UDT definition that I created in Ignition. I'll click into it. And then here under Measurement Definitions, you can see my two properties, temperature and turbine speed. Next, I'll navigate to Assets here on the side menu. And here you can see that I have my wind turbine instance, wind turbine 1, associated with the UDT instance that I created in Ignition. So I'll click into it. And then go to Measurements. And here you can see the value of my tags. And as I adjust the value of my turbine speed using my voltage signal generator, you can see it change there. So I'll adjust it again. And there you can see it change instantly. So we have successfully integrated MQTT Sparkplug data published from the edge with AWS IoT Sitewise platform. And once your data is on AWS Sitewise, you can leverage a host of other AWS services such as AWS IoT Analytics, Amazon Athena, Amazon SageMaker, and Amazon QuickSight to perform analytics and build machine learning models.